What if the secret to truly sustainable building was in something as simple as fiber? Forget everything you know about concrete. This video reveals a groundbreaking method of reinforcing foam concrete with fibers, a material that is not only incredibly durable, but also environmentally conscious. Prepare to be amazed by the hidden power of nature in engineering. The construction industry accounts for 37% of global carbon emissions, and traditional concrete is one of the main carbon sources. But today, a revolution is quietly taking place. Fiber reinforced foam concrete, which not only dramatically reduces carbon emissions, but may even be carbon negative. Imagine a material that possesses the lightweight insulation properties of foam concrete and compensates for its strength deficiencies through fibers, while using agricultural waste to reduce resource consumption. This is no longer science fiction, but a realistic breakthrough in materials science. Limitations of conventional foam concrete. Why the need for innovation? Although traditional foam concrete has the advantages of lightweight, heat preservation, and waste utilization, there are three major bottlenecks. 1. Strength and density contradiction. Density lower than 300 kilograms per cubic meter. Compressive strength is only 0.2 to 0.33 megapascals. Easy to crack and absorb water. 2. Insufficient durability. Microcracks expand under dry and wet cycles. Strength decreases non-linearly with increasing porosity. 3. Production relies on manual labor. Domestic equipment lacks standardization. Proportioning relies on experience, and quality is unstable. These limitations restrict its application in load-bearing structures. But the addition of fibers is changing the situation. Fiber reinforcement. Synergy of nature and technology. Fibers are the natural skeleton of foam concrete, and their benefits stem from three core mechanisms. 1. Diversity of fiber sources. Synthetic fibers. Polypropylene PP fibers length 3到18毫米 to enhance crack resistance. Polyvinyl alcohol PVA fibers to enhance toughness. Agricultural waste. Straw, cotton stalks, and other plant fibers, both to reduce costs and achieve resource recycling. Industrial byproducts. Fly ash replaces part of the cement, reducing carbon emissions. A leap in mechanical performance. Tensile strength enhancement. Fibers form a three-dimensional network in the B concrete to inhibit crack expansion. For example, when PP fibers are combined with recycled aggregates, the compressive strength can reach 6.5 MPa, and the flexural strength is elevated to 1.62 MPa. Ductility and impact resistance. Blended fibers, for example, PP plus PVA, give the concrete strain, hardening properties, and impact energy consumption is elevated by more than 60%. Durability enhancement. Fibers reduce crack expansion under wet and dry cycles, and the rate of pore area rate growth is reduced by 30%. Practical application cases. Post-disaster reconstruction. Foam concrete is used for roadbed filling, and the load-bearing capacity is increased by 40% after fiber reinforcement, and the construction speed is increased by 50%. Green building. Tanji University patented technology to make NON load-bearing wall with plant fiber, which reduces thermal conductivity by 70% and is completely formaldehyde-free. The science of sustainable reinforcement. From laboratory to reality. The success of fiber reinforcement depends on precise process control. Mixing ratio, 0.3% by volume of fiber. Blending is the golden point. Excess will lead to agglomeration. For example, with recycled aggregate plus 0.3% PP fiber. The flow degree reaches 183 millimeters, balancing workability and strength. Curing process. Standard maintenance, 28 days. Mixed with early strength agent can shorten the cycle, while water retention agent to prevent cracking. Greening tomorrow. A win-win situation for the environment and the economy. Fiber, reinforced foam concrete is not only a technological innovation, but also a win situation for ecology and economy. 1. Environmental benefits. Carbon footprint reduction. Replacing cement with fly ash, straw, etc., reduces CO by 30% per cubic meter of concrete. If combined with carbon capture technology, for example, calcium carbonate curing, it can be carbon negative. Waste reuse. Agricultural fiber consumption of straw and hulls to solve the problem of burning pollution. 2. Economic benefits cost advantage. Plant fiber concrete raw material cost is reduced by 20%, and the return on investment is high, for example, annual output of 4,000 tons scale. The profit can be up to 8 million yuan. Policy dividend. China has included low-carbon concrete in the Green Building Materials Certification, and the mandatory procurement ratio for municipal projects reaches 15%. 3. Policy and innovation drive. Carbon pricing mechanism. Carbon tax subsidies in Europe and the United States amount to $85 ton CO, incentivizing enterprises to transform. Technology promotion. Need to develop standards, for example, ISO 23904, and increase R&D investment to promote the maturity of the industry chain. Fiber, reinforced foam concrete proves that sustainability is not a compromise, but an upgrade, lighter, stronger, and greener. From self-built houses in rural areas to demonstration projects in Zhang and new area, this revolution is reshaping the way we build. The next time you choose a material, remember, every fiber is a bridge to a low-carbon future.